Hey, leopards. Okay, guys, today we're going to talk about something that's a little bit more in depth with probability. They are called disjoints and overlapping events. Now, wait a minute. What does all that mean? So guys, I'm going to give you a visual representation of what this means, and I'm going to show you guys some key words that you're going to want to remember and write down in your review. All right, let's take a look. So, right here, guys, it says that we have an intersection. Okay, an intersection is the collection of all outcomes in both sets. Now, what does that mean? Okay, so that means and. Anytime you guys see that, like, we've been doing this, the probability of flipping a coin and, okay, the probability of drawing blue out of the bag. Okay, those are intersections. We want the probability of both. Hey guys, whenever you see the keyword and, you are going to multiply the probabilities together. Okay, multiply the probabilities together. Okay, and visually what this looks like is right here. Okay, that's the intersection. You guys have done some Venn diagrams before. This is a Venn diagram. So the intersection is where they, okay, that's the outcomes in both sets. I need some chocolate, guys. Okay, the union, okay, the union is the collection of all outcomes in either set. So do you guys see the keyword or? Okay, so whenever you see the keyword or, that would be like, hey, what is the probability that you draw a king or a heart out of the deck? Okay, there's two things, and we want either or of those to happen. When you see that, guys, or means you're going to add the probabilities. Okay, it means you're going to add the probabilities. And this is what that Venn diagram looks like. Okay, so we want, whether it's a king or whether it's a heart, or whether it's both a king and a heart. We want the union. The union is the collection of all those outcomes. Okay, now we have what's called compound events. Okay, and I'm going to talk a little bit about this because, guys, what we're going to do is see that there might be some overlap. Okay, so if you guys notice right here, this is just another visual representation. Here is the union of A and B, and notice it says A or B, okay? So wait a minute, what did I just say? That if it says the word or, what are we supposed to do to those probabilities again? Yeah, guys, we're supposed to add the probabilities when we see the keyword or, okay? And again, here is the intersection of A and B, okay? So if we see the keyword and, then what are we supposed to do to those probabilities? Yeah, we're supposed to multiply those, aren't we? I just talked about that up above, didn't I? Okay, so this is the intersection of A and B, and we're just looking at this part right here. That's what we want to find the probability of. Okay, now, over here, we have this set, and guys, that's called an empty set. Okay, that means that those are completely two independent probabilities. Okay, we're not joining them at all. Okay, now I told you guys just a second ago we were going to talk about overlapping events. Okay, overlapping, and guys, I'm gonna circle this right here. Overlapping is where the two events have the same outcome. Okay, so for instance, okay, if I were to say you draw out a king or you draw out a heart, okay, out of the deck. Hey guys, can't a king also be a heart? Yes. So that is considered an overlapping event. And these are important. I'm going to show you why here in just a second. Okay. So when two events have one or more outcomes in common, okay, that means where they overlap. Okay, disjoint events are where there's no common outcomes. Okay, no common outcomes. So that would be like me saying, hey, you know what? Let's draw a king and a 4 out of the deck, right? Well, a king can't be a 4, and a 4 can't be a king. Those are two independent things, aren't they? Okay, there's no overlap. They can't be the same. Okay, now, probability of overlapping events or compound events. So let me talk about this. Okay, if A and B are overlapping, so that's like the one where I said that you have a king or a heart, okay? That one is overlapping. Then what you do is you take the probability that you draw a king, you add the probability that you draw a heart, and then you subtract all of the kings that are a heart. Well, guys, in a deck of cards, we have one king that's a heart. Okay, so that's kind of how this looks, is that when they overlap, we subtract that overlap because we don't want to take that probability twice. That skews our data. Okay, now, if we have disjoint events, like I just talked about, we draw a king or we draw a 4, there's no overlap, we just add those probabilities together. Okay, now, guys, this is a lot of like P's and A's and P's and B's and all this good kind of stuff. So let me show you how this looks, okay, as we go through this assignment. All right, let's go down and we're going to take a look at number 7. Okay, so I'm going to meet you guys down at number 7. All right, ladies and gents, we're down here at number 7, and I want you guys to notice on the instructions it says for 7 through 11, you're going to randomly select one card out of a standard deck of 52 playing cards. Oh, that was nice of them. They told us there's our total sample set, isn't it? Okay, so we're dealing out of 52 cards. Now, number 7 says that it says, what is the probability that a card is a 9 or the card is a jack? So, guys, we see that keyword or, don't we? Okay, so that means that we're going to add those two probabilities together. So here's what that looks like. First of all, we got to find out what is the probability that we pull out a 9 out of the deck. And then we have to see what is the probability of pulling a jack out of the deck. And then we have to ask ourselves, is it possible for a 9 to also be a jack? What do you guys think? Can a 9 be a jack or a jack be a 9? No, a 9 can't be a jack. So there's no overlap. Okay, since there's not, a 9 can't be a jack, that means that there's no overlap. Okay, so since there's no overlap, we are just going to add those two probabilities together. Okay, so let's find the probability of pulling out a 9. Now, just in case you don't know how many 9s are in the deck, guys, in your flip chart and in your formula chart, we have the deck of cards for you. So I want you guys to go and look on that chart, and can you tell me how many out of 52 cards are a 9? Okay. What about jacks? How many cards are jacks out of the 52? Okay, so did you guys say for both of these, there's 4 9s out of 52, and there's 4 jacks out of 52? Okay, good. So now we're going to take those two individual probabilities and we're going to add them together. So 4 over 52 plus 4 over 52. We're going to add them together. And since a jack cannot be a 9, there's not an overlap to subtract, is there? Okay, so we're just going to find that total probability. All right, in your calculators, guys, why don't you give this a try? And I want you guys to tell me, in a percentage rounded to 1 decimal place, what is the probability that we would draw either a 9 or a jack out of the deck? How'd you guys do? Okay, so when you put this in your calculator, okay, some of you may have to put parentheses around the fraction before you add it. Okay, it depends on what type of calculator you have. Okay, but hopefully you will get that it's 15.4%. Okay, so is that a high probability that we're going to draw a 9 or a jack? Nope, it is not very likely that we would draw that out of a deck of cards, is it? Okay, all right, now, that's an example where we do not have any overlap. So that is a disjoint event. So we just did a disjoint event. Now let's go down and, hey guys, let's go down and look at number 11. And I'm going to show you something a little bit different. Okay, so down here at number 11, we're still going to be pulling one random card out of 52. But this time, we want to find the probability that the card is black or the card is an ace. Okay, we still need to find the individual probabilities of both. Okay, so the probability of drawing out a black card and the probability of drawing out an ace. Okay, we're going to find those individual probabilities. Okay, so you guys, here we go. Can you guys tell me in fraction form, what would be the probability of drawing out a black card? Now remember, black can be all the spades and all the clubs. So what would that probability be? Did you guys go and look and actually count up how many spades and how many clubs that are black? There's 26 out of the 52 that are black. Okay, well then, wait a minute. What would be the probability then in a fraction form of drawing an ace out of the deck? Yeah, so did you guys see that there's 4 out of 52 cards are aces? Okay. Now we have to ask ourselves before we go any further, guys, can a black card be an ace? Or can an ace be a black card? What do you guys think? All right, so hopefully you guys said, hey, yeah, Miss Smith, there's an ace that is a club, and I'm going to try to draw my little club over here. And there's also an ace that is a spade. So both of those are black cards, aren't they? So there's actually 2 cards out of the 52 that are both black and an ace. Okay, so that means I need to find the probability of both. The probability of both. There are 2 aces that are also black. Now, the reason why I need that, ladies and gents, this right here is your overlap. Okay, and remember, we have to subtract the overlap because we don't want to count the probabilities twice. Okay, we have the keyword of or up here. So we're going to add all of these probabilities, except we're going to subtract the overlap, aren't we? Okay, so it looked like this, 26 over 52. That's the probability of drawing a black card, plus the probability of drawing an ace. Okay, and then we're going to subtract the overlap of the probability of both of those happening. Okay, so guys, I set it out for you. Can you guys please tell me, rounded to 1 decimal place in a percentage, what is the probability that we draw out either a black card or an ace? Okay, how'd you guys do? Okay, so remember, you're going to add the probability of the black and the ace, but then you're subtracting the overlap, the 2 aces that are also black cards. So it is a 53.8% chance that we will draw out a card that is either black or an ace. Okay, so I just showed you guys on this, okay, how to find the probability of overlapping events. Okay, I'm going to go ahead and work one more with you guys. We're going to go down and take a look at number 18. I'll meet you down there. All right, y'all, down here at number 18. This is, I set this up this way so that you guys could visually see and you can actually mark and see where the overlap happens. Okay, so if you're a type of person that likes to use highlighters, go get your highlighters. I'm going to show you something. Okay, so in this particular problem right here, it says 2 6-sided dice are rolled. Hey, just like we did in our activity, right? Okay, so it says find the probability that the sum, right, that's when we add them together, of the numbers rolled is either even or is divisible by 5. Okay, now, guys, there was a key word in this sentence that will tell us, are we going to add those probabilities together or are we going to multiply those probabilities together? What do you think? Add them together or multiply them together? Hopefully you said, hey, Miss Smith, we're going to add them together because this said the keyword or, right? Okay, now visually, let me show you how we figure this out. With the dice, first of all, it's the sum of the dice, isn't it? Okay, so I'm going to start on the top row. 1 plus 1 is 2. That's even, isn't it? Okay, well, 1 plus 2, nope, that's 3. That's an odd number. 1 plus 3, hey, that's an even number, that's 4. Now, I'm going to go through all of these, and I'm going to mark down the even numbers. But check this out, you guys. If I go down diagonally, 2 plus 2 is also 4, and 1 plus 3 is also 4. Oh, those are all even, aren't they? Okay, so I could do it like that, or I can actually go and write the sums. Okay, so the sum up here of this diagonal, okay, the sum of those is 2, the sum of those is 3, the sum of those is 4, sum of those is 5, 6, and 7. So that means that diagonally, this whole diagonal right here should add up to 6. And 6 is an even number, isn't it? Oh, okay. But now, hey guys, don't we have more that we can still roll above 7? Okay, so we can go down and say, okay, wait a minute, what about 8? Okay, so 6 plus 2 is 8, isn't it? Okay, so let me put an 8. This row would be 9. This one would be 10, 11, and 12. Again, this is diagonal. Okay, I would go to 6 plus 2. Okay, 6 plus 2, 5 plus 3. Oh, this whole row right here. 4 plus 4, those are even. Okay, and then the 10s that add up to 10. These three right here. 4 plus 6, 5 plus 5. And then this diagonal right here, 6 plus 6 is 12. Those are all the even dice. Okay, that's a lot. Now, I do that to show, okay, we can count these now. Okay, if we go and count these, we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Did you guys count 18 with me? Okay, so the blue, okay, this is the probability that we roll even. There are 18 out of how many possible? Well, guys, what is our total sample set? How many different ways can we roll 2 die? Did you guys count them all up and say, hey, Miss Smith, there are 36 different ways that we can roll those dice? Okay, now we need to find the probability that it's divisible by 5. So probability, and I'm going to abbreviate, divisible by 5. Okay, what is the probability divisible by 5? So guys, now let's go take a look and let's go highlight which of these sums is divisible by 5. Well, 2s are not divisible by 5. 3 isn't divisible by 5. 4 is not divisible by 5. What about 5s? 5 divided by 5. Yeah, that works, doesn't it? Okay, so we've got these right here. All of these are divisible by 5, aren't they? Okay. What about 6s? Nope, 6 is not divisible by 5. What about 7s? Nope. 8s? Nope. Well, guys, look at the ones that are left. 8, 9, 10, 11, 12. Are any of those divisible by 5? Yeah. Okay. 10, isn't 10 divisible by 5? So that means that any of these that add up to 10 are also divisible by 5. Okay. Now, how many of these are divisible by 5? So how many out of 36 are divisible by 5? All right, what'd you guys come up with? Did you come up with 7 out of 36 are divisible by 5? Okay, good job. Now, guys, this is a visual representation. Now, I want to ask you guys, do you see any overlap? Let me zoom in right here. Do you see any overlap where the blue and the red are both on the same sum of dice? And if so, how many of these overlap? Oh, did you guys see that right here, this row right here, these 3 overlap, don't they? They're both even and they're both divisible by 5. So we need to do, what do we need to do with that overlap again? Okay, we're going to come back here and we're going to see. We've got the probability of both. Okay, so the probability of both. Well, let's look. We said that there were 3 out of 36 that are both. Okay, now I just asked a question a second ago. What do we need to do with that overlap? Okay, did you guys remember that we're going to subtract the overlap? Okay, we're going to subtract the overlap. Okay, so let me scroll down here and we're going to set up our equation and we're going to see what you guys come up with. Okay, so we've got the probability of even. Okay, and then we said earlier we're going to add those probabilities because it says or, plus the probability of divisible by 5. And then I just said we're going to subtract the overlap. So we're going to subtract the probability of both. Okay, guys, you have your numbers. I gave you kind of the little formula. Can you guys tell me in a percentage rounded to 1 decimal place, what is the probability that we will roll a sum that is either even or divisible by 5? How'd you guys do? Okay, did you come up with 61.1%? Okay, so look at my work, compare it to yours, see how, if you made a mistake, what might have happened. Okay, so again, guys, this is a visual representation, and I put the dice on your assignment specifically so that you could do the highlights if you need to. Okay, so visual representation of overlapping events. All right, so we have gone through, we have done disjoint events, we have done overlapping events, we have added probabilities, and we're going to get a chance to multiply some probabilities in some different problems. All right, as usual, ask questions. We'll see y'all in class to finish this up. Adios!